Hello, YouTube. Kindly consider the following problem. What if we want to represent a Roman numeral? Alrighty, let's find out about this. Let's see. Let's connect to server. Yeah, man. And let's see. I think we were in lab. What was. Roman, yes. Alrighty, so, okay, I'm going to make a folder. How did we do this last time? Hang on. Didn't we do part A? Okay. Alright, so let's do that. So, we did Roman in class, but we never got to record it, and that was some time ago. So here we go. Let's make a new folder called Roman. How about Roman A for the screencast, okay? And in Roman A, let's make a Roman tester document or file. I'm typing that backwards. Roman tester.java and the Roman class itself. Alrighty. And what I'm going to do is eventually we're going to talk about using static arrays, 1 and 2 dimensional static arrays to do this. But today let's just do it without arrays. Alrighty. So in the tester, let's say, okay, public class Roman tester and then public static void main string array args. That's also static string array that we use for input. In fact, let's do that. Let's get a number from the command line, and let's restrict ourselves to a 2-digit number for now. Eventually we'll get more digits. Let's see. Yeah, let's restrict ourselves to a 2-digit number. Alright, so let's say int num equals new Roman, and let's take the input from the command line args0. So using the first element of the string array args. Alright, so what are we going to do? We have a Roman numeral, right? So how about we... Alright, let's start with just the print line with a 2-string. Okay, so eventually we're going to have 2 numbers. I want to add them, subtract them. So let's make this num1. Okay, so how about system.out.println let's see. Oh, that's boring. How about I call it Caesar, just for fun. And let's print line Caesar, right? Okay, that's all I want to do. So we're going to override the toString method we inherit from the supercosmic object class, because technically this extends the object class, but that's by default. You don't have to write that. So we might want to do that with the dot equals method too. Alright, but that's enough for now. Let's see if we can get this to print out properly. Let's go back to here and write the constructor and the toString method. Okay, so how are we going to do that? Well, let's see. Public class Roman, and let's start with the constructor. Let's see, public or not, public. Void or not, neither. You usually say void, or is it like an int or a string or something? It's not an accessor. It's not void, by the way. It's a constructor, so just the name of the class is the name of the file, is the name of the constructor. And it takes an int. Let's call that num. How about that? And all I'm going to do is store that in a private instance field of the same name. So this dot num, or my num, I guess you can call it, equals num. And so how are we going to do a toString? Well, let's see. toString public or not, it's got to be public. We're using it in another class. Void or not, no. It returns a string. and toString, this is the signature line, just like that. Okay. We could use the override decorator to make sure we're all writing correctly, but leave it at that. Alright, so what we're going to do is going to create a temporary string that we can print line. Let's initialize it to the empty string. We're going to do stuff to it, and then we're going to return temp. So what do we want this to look like? Well, now remember, we're restricting ourselves to 2-digit numbers. How do we get the ones place? Like, say the number is 23. Well, since it's base 10 number, if you mod it by 10, you get the 3, and you div it by 10, you get the 2, right? So 23 mod 10 is 3, because that's a remainder when you divide by 10, and div 10 is 2, because that's how many times 10 goes into 23, for example. So int ones equals num mod 10, and int tens place equals num div 10. And since these are integers, it's a div, not a normal derive that gives you a double. I mean, divide that gives you a double. And then we have to figure out what 1 is. Like, if the ones place is in fact a 1, then temp, let's say, whoops, where am I? Temp plus equals, concatenating, quote I, right? Isn't that how you write the Roman numeral 1? And what if the tens place equals, it's an equals, whoops. What if the tens place is a 1? Well, let's do the example we did. We said 23, all right? Let's say the tens place is a 2. And we say temp plus equals. Now, how do you write it? 20? Isn't that XX? And let's see if that's enough. Now, notice there's a lot of stuff missing. What about all the digits in the ones place? All the digits in the tens place? We're going to eventually use a static int array or a string array or something to figure this out. Okay, so but let's see if this works for now. All right, so let's shell out and shush in. That's not it. There it is. All right, let's CD. It was lab 707. Yes. CD Roman. They do that all the time. A. Okay, so let's see what we got in here. All right, so it's Java C Roman tester. And what? Ooh, I messed up. What did I do? Whoa. Oh, wait. Let's make some room here. Alright, what did I do? Oh, I can't spell print line. Well, let's start with that. In the tester, line 7 and line 5. Oh, well, I didn't put the number. Hey, of course not. Wait, no. I didn't Java it yet. Why doesn't it like arg0? Oh yeah, because it's a we're inputting we're taking input from the command line, which is a static string array. You have to convert the 23 into an integer. Whoopsie. All right, let's fix those two things. So in the tester, it was print line. Thank you. And here I'm going to need to say integer dot parseInt the arg0. Whoopsie, sorry. Because that's coming in as a string. Alright, let's try that. What did I just do? And whoops, now what? Oh, I did two things at once. I'm sorry. I have a big, bad herniated disc in my neck. It's distracting me. I'm messing things up that are silly. Please excuse. Hang on. What am I doing? I want to do this. Well, okay. I want to do this in two separate lines. I want to get rid of this. Alright, that's the input, right? That's an integer. And then we're going to construct Okay, let's say this is num1, and then let's construct a Roman type called Caesar equal new Roman num1. That's what I meant. Sorry, I did everything one line. You can't do that. Let's just check my notes. I should check my notes, shouldn't I? Yeah, that would be good. Okay. So leave it at that. Let's see what we did now. And what do I do now? Oh, I didn't write the private instance field. Yay. Alright, so in Roman, notice we need a private instance field, right? So private int num. And each Roman object is one Roman numeral, so just num, not num1, num2, right? Alrighty. And let's do that. There you go. No, what happened? What? There you go. Alright, so let's Java it. And of course, you know, that's an error because we're putting 23 here. Here. Oh, now wait a minute. What happened here? Why is it doing that? Let's see. I entered 23. And what the heck? What the heck did I do? Okay, hang on. I can't see my smartboard here. Okay, so if the 1 is a 3, yeah, that would be nice. There you go. If the 1's place is a 3, okay, so this should work for 23, right? Yeah, except it's backwards. Why? Well, because we're concatenating backwards, that's why. Right? We put in the 1's place, and then we concatenate the 10's place. Why is that backwards? My notes say to do it this way, but obviously that's backwards. That is backwards. So how about we do this? You can't do a plus equals. How about the 3? The 3 plus whatever's in temp. Let's do it in that order. Instead of the temp plus equals the shorthand for temp equals temp plus 3. So it puts the 3 on the end, but then we put the 20 on the end. We don't want that. So let's do it backwards. Instead of temp equals temp plus 3, make it temp equal 3 plus temp. So the 3 comes first, then the, right? Okay, let's do the same thing here. So I can't do a plus equals. Alright, let's try that. That's a 23. Okay. Now, what if I run it for something that's not in there, like 20? It messed up. Or 10. There's nothing there. Or, what if you don't realize what happens if you don't even define a toString? Then you've not overridden the toString method. It'll use the default toString method from the object class, which will only tell you, I think, the name of the class and the hexadecimal address in RAM referencing where this object is stored, this Roman object. Just for fun to see what that does. No matter what you input, 23, see? So the name of the class and where in hexadecimal format, where in RAM this object is stored. Look at that, okay? Even if you change it, So you need your toString, right? So let's fix that. So get rid of this. So clearly there's an easy fix. Now you have to do all the ones, right? So let's see, there's the, we're not going to deal with 0. 0 is a blank, in other words. So Romans didn't really have numerals for zeros. So 1 through 9 digits, and 10 through 90 in the tens place. So just the ones place in the tens place. So let's see, we need 2 more of these beforehand. For 1 and 2. Whoops. And we need 2 of these beforehand. For the 10 and the 20 and the 30. How's that? So I can do, oops, that's wrong. Okay. So I can do 1 through 3 digits, 1 through 3 in the tens place. Alright, so I could do that, I can do that, I can do that, I can do that, I can do that, but this isn't going to work, basically. Whoops, what's that capital X in there? Alrighty, get rid of that capital X. Alright, so just doing a toString right now. Eventually we're going to want to talk about adding and subtracting and multiplying, as long as our input and output is 2-digit numbers right now. And since we're overriding the toString method, how about we override the equals method, and maybe we even implement compare to from the comparable interface. So we'll get to that. Alright, so now I need, what, 6 more of the ones. So it's 1 through 9, right? So 4, 5, 6, 7, 8, 9, and this is 4, and this is 5, and this is 6, and this is 7, and this is 8, and this is 9, right? Okay, and the same thing for the tens place. And the toString is basically done for 2-digit tens place integers. Base 10 integers. So that's 30, this is 40, this is 50, this is 60, this is 70, this is 80, and this is 90. Let's make a, let's see, 90, let's make C 100, so XC, 10 less than 100. Alright, so there you go. And let's try that. Alrighty, so Java it's, alright, so I could do 11, I could do 12, I could do 13, I could do 14, 14, I can do 15, I can do 16, I can do 17, I could do 18, I could do 19, and I could do, let's see, 29, and 39, and 49, and 59, and 69, and 79, and 89, and 99. That works. Yeah, that's good. Unless you want to space it out maybe a little bit. Yeah, why don't we do that? Let's throw in a little space. So that our toString will be nice. How about, let's see, how about a space between the x and the I, between the XX and the II, and between the XXX and the III, and so forth. Not that much. Just one space, just one space. Just space it out a little bit. Alright, let's see what that looks like. that, and so forth. Okay, that's nice. All right, so while we're at it, how about we let's implement the compare to method from the comparable class, so we can use that to make an equals method overridden from the object class. So let's go over here. Let's say implements, just for fun, I'm gonna say extends object. You can only extend one class at a time. Implements comparable of Romans, comparing Romans only. And by the way, you can implement more than one interface with separated by commas, right? Okay. So let's do, how about down here? Let's do the comparable. Sorry, compare to, and compare to, well, the easy way to do compare to is, well, this is the signature line, that's defined in the interface. Public int compare to, in this case we can do Roman other, because we specified that in the implements command. Alright, so Roman other, dang it, I did it again. Roman is defined, others, you can call it anything you want. You can call it Alfred for all I care. And a real typical way of doing this now, if the first guy, if this dot compared to other, right? If this is less than other, return a negative. If this is equal to other, return 0. If this is greater than the return a positive. The easy way to do that would be, how about return this dot, I need a get num to access the private instance field of the other, don't I? Alright, so I don't need this dot get num for this, I can just do num minus other dot get num, and there you go. Now that means I need an accessor for get num. How about we put that up here? This is a standard accessor. Public int get num simply returns the private instance field num. Alrighty, so return num. Okay, so now how are we going to test that? I usually do that in the tester. Let's get two numbers to compare. How about Brutus? Num2 will be Brutus. Let's see, and let's do an if statement. Let's see, how about if, well, let's print line both of these. How about this? Quote, Caesar equals, concatenate, and Brutus equals, concatenate, Brutus string. Alrighty, and then how about if Caesar dot compared to Brutus is less than 0? Then we'll just print line Brutus is less than Caesar is less than Brutus, right? So system dot out dot print line, but there's three cases. There's equal to 0 and greater than 0, right? All right, we'll get to that. Let's see, Caesar is less than Brutus. There you go. How would we do equal to? Well, we could do equals equals 0, or we can do the dot equals method, right? So let's see, that's a Boolean inherited from the object class. So let's go to Roman, and let's do the equals method. Alright, so that's public, Boolean, equals, see, how did I write this? How did I write equals? There it goes. Equals, and we're inheriting this from the object class, so it's object other. Alrighty, and what we're going to do is return true if compared to returns 0. How about that? So how about, alright, so first we have to cast other to a Roman. We have to morph it. Okay, so there's polymorphism, Roman, because it's not only an object, it's a member of the object class, it's also a member of the Roman class. So Roman, I don't know, temp equals cast or morph to Roman, the other, the object we called other, and then we'll just return this dot compare to temp. Those are the two Roman objects that compared to is defined to 4. If that's 0, that equals is true, otherwise it's false, right? Okay, let's save that. Let's go back to the tester and let's do an if statement for that. Okay, so if Caesar dot equals other, it's already true or false, so you don't have to say if it equals true. Then they'll say we're equal. And what about the less than case? Well, so the greater than case, how about copy this and do it the same way. If it's greater than 0, whoops, then we'll say it's greater than 0. So we didn't have to do that equals, just could have done compared to Brutus equals 0, but same idea. So we have an equals method, we have a compared to method, we have a toString method. Okay, so we've inherited and overridden everything we need to do. Let's test it. Alright, so is 57 greater than 33? 57, wait, what? They're both 57, so they're equal. Yeah, that's the problem. What happened? In the tester, I put numeral 1 here. It's 2, okay. And this is 0, 1, good, that's right. Okay, whoops. Alright, clear. Alright, so that's clearly a less than. I'm sorry, greater than. That's clearly greater than. Alright, let's change it up. How about 7? Yep. How about, let's make them equal. That's good. That's, yeah, nice. Perfect. That's it. Alright, so how about adding, subtracting, and multiplying? Well, let's see. How about, let's go to the tester. Are we in the tester? Yeah. How about, let's do the adding and stuff. How about we say Roman, dang it, sum equals Caesar dot add Brutus. Okay. And then system dot out dot print line. What are we gonna write? How about we write it out? Let's see. Caesar concatenated, because that's a string with a toString. Quote plus sign quote plus Brutus. That's just not a plus, a concatenate. I concatenate here. Quote equals quote concatenate sum. That doesn't fit too well. All right, how about, all right, let's minimize the number of spaces we need here and here outside the quotes. There you go. How about that? Be consistent. All right, let's see if that works. Save it. It did? Okay. And clear it. And Java C it. Oh, I didn't write add. Duh. I gotta write the add method. Alright, so let's go to Roman. Let's go down here. And let's see, the add method, how's that gonna work? Well, we're going to add two Romans and we're going to get a Roman, right? So public Roman, it's going to return a Roman. Add Roman other. We're adding two Romans and we're going to spit out a Roman. Is it this Roman and other Roman and the output? And how about we return an unnamed object we construct right here on the fly of this.getNum plus other.getNum. Again, you don't have to say this.getNum, you just write num, but other.getNum because it's the other object. Alright, so this.getNum, just to be consistent, I suppose, plus, now these are ints, so you can do that, and then we construct a Roman based on the sum of the two ints, other.getNum. And that should do it. Let's see if add works and sum works and all that fun stuff. Alrighty, and there. So let's add them. So 7 plus 7 is 14. Nice. How about, now remember, the output can't be more than 2 digits, can't be more than 99. So how about 17 and, I don't know, 23. 17 plus 23 is 40. Yeah, that's it, right? Nice. And 17, alright. And how about, I don't know, 55 and 21. Should be 76. And that's 76, isn't it? Alrighty. And we got equals, we got less than, we got greater than. Okay. How about, what's the most we can do? Can we do 77 plus 22? What happens if we do, I don't know, 222? It doesn't know what, yeah, that's a mess. Alright, but that's working for two-digit numbers. That's nice. And guess what? How you can do difference. You can do, whoops. Let's see. You can do a difference and you can do a product the same way. Let's see, let's try this. So the diff, let's say. How about subtract? And let's make the sub or subtract method the same way as this. How's that? Just subtract the ints. Okay. So let's subtract 77 minus 22. So 77 plus 22 is 99. Yep, there you go. And 77 minus 22 is 55. Hey, that's nice. I like it. Alrighty. And by the way, we're not dealing with negatives, so don't subtract a larger from a smaller. Like this won't work. Right? There's no output for the subtract. Oh, this is wrong. We should fix that. Okay. In the tester, this should say minus here. And let's do product. Okay. How about prod? And how about, I don't know, mul for multiplying? And how about a times symbol here? And let's call this prod. And let's do the same thing here. Alright, let's see if that works. Now it's going to have to be really small numbers, like 2 and 7. How about that? Alright, so 2 plus 7, 2 minus, wait, what happened? Something, oh yeah, well first of all I can't do 2 minus 7. Alrighty, what happened here? It's not prod, it's mul. Dang it. Alright, save it. Alright, clear that. And so be careful when you're subtracting, the first number has to be larger. We're not dealing with negatives or zeros. So the first, so how about 7 plus 2, 7 minus 2 is 7 times 2. 7 plus 2 is 9, 7 minus 2 is 5, and 7 times 2 is 14. Okay. How much bigger can we make this? How about, I don't know, can we do 11? No, again with the subtract, okay. Let's do 11, 7. 11, 7. So 11 plus 7 is 18. And 11 minus 7 is 4. And 11 times 7 is 77. That's it, perfect. Alright, so let's leave it at that for now, YouTube. Thanks for coming. That was fun.